A very good morning to Professor Dr. Azaha Kamila. This is BITI 2223 Machine Learning Mini Project presentation. Our topic is comparison analysis prepared by Team 9, SEM 1 2021/2022. This is our Team 9 member list. Our presentation consists of executive summary, project background, objective, scope, project significance, tool and algorithm, result, comparison analysis, and conclusion.
Okay, I'm Sukaita and now I'm going to present the executive summary. So this project is about comparison analysis which compare two or more types of machine learning algorithm on different datasets in order to find the best for each dataset. The datasets found for this project mainly for patient, diabetes, and cell samples. For this project scope, 4 algorithms are used for binary classification, which are logistic regression, random forest, support vector machine SVM, and KNN for K nearest neighbor. Feature engineering for the data pre-processing stage will be constant for this project. Next. So the project background, the 3 datasets. The first one, patient survival, is predict whether a hospitalized patient will survive based on the factor. The aim is to develop a prediction model for all cause in hospital mortality among patients. The patient dataset is multivariate dataset that contains of 91,713 instances, and the data include 85 features in one label hospital there. Next, the dataset is diabetes. It predicts the patient has diabetes according to the diagnosis measurement. The diabetes dataset original from the National Institute of Diabetes and Digestive and Kidney Diseases. All patients are female at least 21 years old from Pinma Indian heritage. This dataset contains 768 instances. This dataset includes 8 features and the number of pregnancy, glucose level, blood pressure, and so on. And is one dependent variable is the outcome. So the last one is the cell sample. It indicates whether the sample might be benign or element from other patient sample. The cell sample dataset consists of 699 instances. This dataset includes a 10 feature of ID, clump thickness, uniformity of cell size, and so on. So the human cell samples characteristics are extracted from patients who have a risk of developing cancer. Next. So in short, all the tasks mentioned above are binary classification that is used to predict outcome between the exactly 2 classes. Generally, the classes is either good or bad, present or absent, and the label as 0 or 1 only. So from the three tasks mentioned above, the outcome are predict the patient will survive or not, the patient has diabetes or not, and the sample is benign or alignment or not, respectively.
And like HENG, there are 3 main objectives in our project. The first one is to classify 3 datasets using 4 different classification methods. Second is to apply feature engineering at data preprocessing stage. And then the last one is to find and compare the best classification algorithms for each dataset. Next slide. For scope, the main area of datasets found is medical or health related in order to ensure a uniformity of the project. There are 4 different machine learning algorithms chosen for binary classification to be compared, which are logistic regression, SVM, random forest, and KNN. These 4 algorithms were chosen based on our knowledge, and the models are commonly used in similar types of problems. Next, feature engineering methods such as feature selection and missing value ratio are applied for data preprocessing handling to ensure the classification task performs well. Next slide. So project significant. As we know, classification is one of the major tasks in machine learning prediction, where it learns an approximation to a set of discrete classes and makes prediction by classifying them into different categories. In this project, binary classification is chosen to classify the elements of a set into 2 groups based on a classification rule. The model is trained and the classification performance is assessed by using a 2-class confusion matrix and calculating the measurements such as sensitivity, specificity, precision, recall, and accuracy. Next slide. In addition, an evaluation metric AUC-ROC graph will also be created to visualize, organize, and select the best classifiers based on their performance.
I'm Anisia. Now I'm going to explain the tools and 4 supervised algorithms used in this project. The online platform used is Google Colab in Python language. Next slide. Logistic regression is a supervised learning technique that uses logistic function to model the dependent variable with 2 possible values, 0 and 1, in binomial model using independent variables. However, the output value instead of 0 and 1 is the probabilistic values between 0 and 1 with the logistic function or sigmoid function. Usually, binomial is for binary classification. Next, SEM is a classification method that often use good classification results from complex and noisy data. It aims to build the best line or decision boundary that can segregate n-dimensional space into classes so that the new data point will be in the correct category. The best decision boundary is for a hyperplane. SEM will choose the extreme points or support vectors that help in creating the hyperplane. Next, random forest is an ensemble learning method for classification, regression, and other tasks that operate by constructing decision trees during training phase. For classification tasks, the output is a class selected by the most trees. Last algorithm is KNN used for classification and regression problems based on the feature similarity approach. KNN classifies the new data points according to the similarity measure of the stored data points. For binary class, an odd number is chosen for the k-value or number of nearest neighbors to avoid misclassification. To find the optimal k-value ranges from 1 to 100, the highest accuracy is chosen from the result of testing on the trained model. That's all from me. Next slide.
Then I and CHENG will continue the presentation with result and comparison analysis. So this is the result 1 from the patient data set, where the random forest has the highest performance, which is 0.8311, the yellow line here. And then the result 2 from the BITI's data set, where the logistic regression have the highest performance in the graph, which is the red line here. And the result 3 from the sample from the cell sample data set, where the logistic regression also is the with the highest performance. Then from the 3 result, we come to the conclusion that according to our finding, the objective and expected outcome are met. The best algorithm compared for each dataset are different, which are random forest and logistic regression. So under the condition where undergoing the binary classification, the dataset with high number of feature and training sample, where the number of feature we set as our height is over 10, and the training sample here is over 1000. So the best algorithm for this type of dataset is random forest. Then the less training for the dataset with less training sample, which under 1000, is logistic regression. That's all from us. Thank you.